The function f is defined as f of x equals x squared plus k squared over x, all and the top bit just square rooted, where k is a positive number. Find the value of p for which f minus 1 of p equals k. Now, looking at this question, what stood out to me was actually if I rearrange this, I could change this to p equals f of k, and life becomes a lot easier. And the reason for that is if you do f of f minus 1 of p, that must obviously equal f of k. So I do f of both sides. Now f minus 1, they cancel each other out. They're inverse functions. So I do tan of tan minus 1. Yeah? Or tan minus 1 of tan. If you have inverse functions, they undo each other. You square root and then square, they cancel each other out. If you square then square root, they cancel each other out. And this then suddenly becomes a much easier problem because p equals f of k. And f of k, well, you just put k everywhere there's an x. So you get k squared plus k squared over k. And you get 2k squared, square root over k. And then we get root 2 times by k over k. So the k's cancel, so p just equals the square root of 2. And if you wanted, you could find the inverse function. I really wouldn't bother. It's a real pain. If you find the inverse function, you need to make x a subject. So we square. Actually, we've probably got to, let's just look at finding the inverse function. So show you why it's a bit of a pain on this question. So you can find the inverse function. So we just get yx equals the square root of x squared plus k. Then we square both sides, yx squared equals x squared plus k squared. Then we take away the x squared. And you get marks for doing all of this, even if you don't get to the final answer. So if you don't know what to do, at least try and find the inverse would be a starting point. And then you get x squared equals k over y minus 1. And then we can see that x equals the square root of k over y minus 1. And so we got our inverse function. So we got f minus 1 of x will equal square root of k over x minus 1. So if we do f minus 1 of p, f minus 1 of p will equal square root of k over p minus 1, and we know that that's equal to k, so we've got k equals the square root of k over p minus 1, and you still got to do all the algebra to find p. It's a real pain. So I suggest that this is the way you want to do this question. So much quicker and so much easier to do it. So that's the way you'd get it. So, but that's all just shows you all the working leading to the other way if you want to do it that way, and it's only for 3 marks. Anyway, so we're now given function g is defined as g of x equals x squared. Given g f of a equals k, find an expression for a in terms of k. So g f of a, well, we know that f of a, so I'm just going to scroll up, get it. So we know that f of a will equal a everywhere as an x. So we've got square root of a squared plus k squared over a. And then we want to do g of that. Now g of that is the square root of that. So g f of a is equal to all that squared. So you get a squared plus k squared because you square the top, and you square the bottom gives you a squared. Now we know that that is equal to k. So therefore a squared plus k squared over a squared equals k. Then we can times that out by a squared. So a squared plus k squared equals k a squared. Get all the a squareds on the same side. So we've got k squared equals k a squared minus a squared. And then we take a squared out as a factor. And then divide by k minus 1. And then square root. So square root at the top gives you k, square root at the bottom, k minus 1, and square root at the right hand side you get a. So we see that a equals k over the square root of k minus 1. So just remember what you had to do here. find out f of a first. That's your result for f of a. Put it into here, so square it to find out what g f of a is. So do g of that after we've done f of a, and this gives you g f of a, and then it's all about the algebra from there on in.